Okay, so last lesson we looked at the compound interest formula and when an amount of money was compounding per year or per annum. So basically, if we have an amount of money, say it's in there for 2 years, so 1 year and then 2 years. If something is compounding per annum, then we get interest paid in there and interest at the end. However, it's not really the usual typical case that interest is going to compound per year. Often it will compound per month or per day, or every quarter or 6 months, depending on what the bank has decided on. Usually per month. So if something is in there for 2 years, we're going to get interest 12 times paid throughout the year and another 12 times in there. So instead of getting interest paid once, twice, we'll get 12 times in here, 12 times in there. Interest will get paid 24 times if the interest is being paid per month instead of per year. So then that means that at the end, we will actually end up with more money overall, which is good for everyone. So this example was actually one that was in last lesson. So I've included the first part again, just so you can see what's happening with the numbers in terms of if we compound per month or per year. So we've got an amount of money invested at that interest rate for 5 years, and it's compounding annually, so every year. So the amount equals 24,500, 1 plus the interest rate to the power of 5. Okay, so using the calculator, trying to work this out. Okay, so you can see we get that amount in there. So 33253.12. Now in part B, we're going to compound per month. Now that means that we will need to change the rate because this rate here is per annum and we need to change the time. So the interest rate before was 6.3% per annum or per year. What would that be per month? And how do we go from there to there? Well, how many months are in 1 year? There's 12. So dividing by 12, 6.3 divided by 12, and you get 0.525%. And the number of time periods, so we had 5 years. Well, how many months is that? That's 5 times 12, which is 60. And those are the new numbers that we're going to use in the compound interest formula. So 24,500, 1 plus 0.525% to the power of 60. Okay, so using the calculator. Okay, and we get a number that's slightly bigger than the one we had before. So 33,543.70. So you can see the differences in numbers. This was if we compounded per year, and this is per month. So because we are compounding those extra time periods, this time 12 times a year instead of once a year, we end up with almost an extra $300 at the end of 5 years, which doesn't sound like a lot, but you can imagine when we're looking at things that have bigger amounts or bigger interest rates or more compounding time periods, you can actually end up with a lot more money. So another example, 35,500 for 10 years, 4% per annum, compounded twice a year. So you need to change your interest rate and the number of time periods as well. So before we had 4% per annum, compounded twice a year. So we want to know, well, what would the rate be per 6 months? Because there's 2 lots of 6 months in a year. So basically just dividing by 2, we'll get 2% in every 6 months. The number of time periods was 10 years. Well, if we split 1 year into 2, how many lots of half years will be in 10 years? So basically timesing by 2, and we'll get 20, I guess 20 half years, 20 lots of 6 months. Okay, and then using those numbers in the compound interest formula. So 35,500, 1 plus 2% to the power of 20. Okay, and then using the calculator, we get 52,751.13. And that's a lot. So looking what we started with, 35,000, what that means in a real life context. If I was to put 35,000 into the bank, leave it, don't touch it for 10 years at that interest rate, compounding every 6 months, at the end of those 10 years, I would have $52,000. That's a pretty big jump from 35 to 52. So yeah, you can see that's how compound interest works, and when we're saving, it's a really good thing to help us to save money.